Hello there guys, welcome back to another epic inexorable maths video. In this video we're looking at multiplying matrices. Now personally I can tell you that I found this very difficult. When I was learning this all those years ago, I found this very difficult to actually grasp, okay? So I am going to try my absolute hardest to make this as simple as it possibly can be. So in this video we're only going to look at multiplying 2 by 2 matrices. In future videos, probably in the next video, we're going to look at multiplying different matrices. So if you already know how to do 2 by 2s, skip this video, it's not worth watching. I'm just kidding, you can probably still get something out of it, but we're just going to do 2 by 2s. In the next videos, we're going to look at all sorts of weird things, okay? So I don't want to make too much of a point on this, because this is going to be mostly for the sake of future videos, but the first thing that you need to know about multiplying matrices is you need to make sure of one thing. You need to make sure that you can actually times them together. So as we said in the last video, and by the way, the link in the description is going to take you to the last video on matrices that I did about what is a matrix and adding them and talking about the dimensions of a matrix. This right here is a 2 by 2 matrix because it has 2 rows and 2 columns. And of course, for the same reason, this is also a 2 by 2 matrix. Now, in order to multiply 2 matrices together, the number of columns in the first matrix should equal the number of rows in the second. So this number should equal this number, which it does. Also, what's really helpful about labeling the dimensions of each matrix before you times them is the resulting matrix will be the number of rows from the first times the number of columns from the second, okay? So that's just really good to know. Now, because they're 2 by 2 matrices, you can always multiply any two 2 by 2 matrices with each other, so don't worry too much about that in this video. That's kind of a next video problem. So how do you actually times them together? You know, how do you actually do it? Well, I'm going to explain right now. So, what you want to do is in some way that I'm about to explain, you are basically going to times the first row of the first matrix by the first column of the second. I'll show you how. And then you're going to times the first row of the first matrix by the second column of the second. Then the second column of the the second row of the first matrix times the first column again, and the second row by the second column. And that's going to be top left, left, bottom right of the result matrix. I will show you how to do it because that's not clear enough, but that is basically what we're doing, because when I was learning this, I was watching people do it and I was thinking, you are just choosing random numbers. How are you doing this? What is the pattern? Hopefully that helps you a little bit, but let's actually go into it. So when I say first row by first column, this is what I mean. I'm going to do the number 1 multiplied by the number 5, and I'm going to add the number 2 multiplied by the number 7. So this number times this number, plus this number times this number. First row, first column. So the top left entry of the result matrix will be 1 times 5 plus 2 times 7. Okay? And we'll simplify that later. The top right entry will be the same first row, but this time by the second column. So 1 times 6 plus 2 times 8. So 1 times 6 plus 2 times 8. That is the top right entry. Okay guys, the bottom left entry is going to be the second row times the first column. So 3 times 5 plus 4 times 7, okay? So 3 times 5 plus 4 times 7. Now pause the video and have a think. What do you think the bottom right entry of the matrix will be? Have a think. If you're really not sure, that's absolutely fine. It's going to be the second row times the second column. So 3 times 6 plus 4 times 8. Okay, so 3 times 6 plus 4 times 8. And that's basically the answer before we simplify it, of course. That is basically the answer. That's how you do it. So first row, first column, first row, second column, second row, first column, second row, second column, top left, top right, bottom left, bottom right. That's the idea, okay? So simplifying this, we're going to have 5 plus 14. We're going to have 6 plus 16. We're going to have 15 plus 28. And we're going to have 18 plus 32. This is going to be 19, 22, 43, and 50. And that is going to be the result of multiplying those two matrices. Hopefully that makes sense. We'll look at another example in just a second. I just want to make a crazy statement because I alluded to this in the last video, but I haven't said anything else about it just yet. What am I talking about? So not only do you need to make sure that the number of columns of the first is equal to the number of rows of the second and blah, 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 the inside numbers need to be the same, but actually something insane happens if you multiply these matrices the other way around. So if I call this matrix matrix A and this matrix matrix B, matrix A times matrix B is not matrix B times matrix A. So the order that you multiply the matrices matters, and you will actually, the vast majority of the time, you will actually get different matrices depending on the order that you times them. That's crazy. So what this means mathematically, the way that you explain that, the way that you say that, is you say that matrix multiplication is not commutative. Commutative is a fancy word for basically saying that you can do one kind of operation one way round and it works the same way. That's if two things are commutative. So you can times two numbers together, that's commutative. 1 times 2 is the same as 2 times 1. So we call that scalar multiplication because those numbers 1 and 2 and 3 and 4, those are called scalars. Those, you can times them whichever way around you want. You can add two numbers whichever way you want too, obviously. 1 plus 2 is equal to 2 plus 1. But multiplying two matrices, this is not commutative, which means you cannot interchange the orders that you times them together. Now you might say, why on earth is that true? How does that even make any sense? Well, it's a simple explanation. Because you're doing different things to different matrices when you times them. You're multiplying the first row by the first column, and then the first row by the second column. And if you swap them around, then rows and columns would be moved, and you would have different numbers in different places. Because again, rows times columns. Well, if I started doing columns times rows, then yeah, I would get different numbers. So that's kind of the idea. Now you might say, all right, well, what mathematician, what genius guy came up with doing that? That's a mess. In another video, I'm going to give you a great example of why this actually makes perfect sense. But for now, let's just do another example. So the example that we're going to do is the exact same question, but we're going to do it the other way around. And I'm going to show you that you do get different numbers, okay? So I'm going to leave this matrix here. Well, I'm going to actually move it to I'm going to put it in orange or yellow here. So I'm going to write 19, 22, 43, 50. This was the product of the matrix 1, 2, 3, 4 with 5, 6, 7, 8. Let's times together the matrices 5, 6, 7, 8 and the matrices 1, 2, 3, 4. So we're doing the same question. This is great because you have another opportunity to see how to do the multiplication, but I'm also, at the same time, going to show you we will not get this. We will get a different matrix. Okay, let's do it. I'll do it down here this time. So guys, have a think about what this will be. Maybe even have a go at it on your own and pause the video and then come back and see if you got the same answer as me. So we're going to do the first row times the first column. So 5 times 1, plus 6 times 3. Okay, that's the first entry, the top left element of the matrix. Then we're going to do the first row times the second column. So 5 times 2 plus 6 times 4. So 5 times 2 plus 6 times 4. Okay. Then the second row times the first column. So 7 times 1 plus 8 times 3. Then finally the second row, the second column. 7 times 2 plus 8 times 4. Okay, and then let's simplify this. I'll do it over here actually, so I don't have to bend down. 5 plus, so this is going to be 5 plus 18. 5 plus 18. This is going to be 10 plus 24. You can already see that you're getting different numbers right now. We've got 7 plus 24. 7 plus 24. And finally, we have 14 plus 32. Okay, let's simplify this. So 5 plus 18 is going to be 23. 10 plus 24 is going to be 34. 7 plus 24 is going to be 31. And 14 plus 32 is going to be 46. And guys, look at that. Completely different matrices. All we did is times the same thing the other way around. And yet we have completely different answers. So that's really crazy, guys. But again, that is for the reason that matrix multiplication is not commutative. Fancy maths word right there. So guys, that's how you multiply at least 2 by 2 matrices. In the next videos, we will look at multiplying different matrices. We're going to look at multiplying weird matrices that aren't square matrices. A square matrix is just a matrix that has the same number of rows as it does columns. So we're going to look at like a 2 by 3 matrix or a 1 by 3 matrix or something like that, timesing those. It's the same idea, by the way. It's the exact same thing. It's just a bit weirder. And we're also going to look at when you can and can't multiply matrices again. So again, it's like being able to tell, can I actually multiply them? Well, actually, you can't multiply those two matrices. And when I do multiply them, what will the dimensions be? And just practicing that. So that's what we're going to do in the next few videos. But for now, guys, I highly appreciate you watching. I hope you found that helpful. Please let me know in the comments whether you found this to be a good explanation of multiplying matrices, because again, this is something personal to me. I found it tough to know how to do this, so I hope I've explained it well. Thank you guys, as always, so much for watching. I highly appreciate it, and I'll see you in the next video.